Okay guys, ozone, part one, ozone basics. So ozone itself is O3, three oxygen atoms bound together. There are three types of UV light that come from the sun. You guys need to know all three. UVC is the strongest, UVB is the moderate energy, and UVA is the weakest. UVC is really important because it's what actually makes the ozone molecules in the stratosphere. So here's what happens. You've got diatomic oxygen molecules in the stratosphere, and they're hanging out doing their little thing, and then UVC comes and bam, splits them apart because UVC is so strong. And then these guys are like, oh no, I'm a free radical oxygen atom. They're very reactive, won't stay single for long. What happens is that free radical oxygen is going to hook up, basically, hook up with a diatomic oxygen molecule, kabam, and it makes ozone. That's how ozone is formed in the stratosphere. Okay, UVC light breaks apart oxygen molecule, the free radical oxygen bonds with the other diatomic oxygens to make ozone, O3. Okay, all of UVC's energy is used splitting up the oxygen molecules. So all UVC's energy always used splitting the oxygen molecules. UVB, the second type of UV light, is actually absorbed by these guys. So ozone absorbs UVB. A lot of the UVB is absorbed by these ozone molecules in the stratosphere, but some of it still does get through. And then UVA is really low energy, and it kind of just goes right through the ozone molecules. It kind of bounces between them. So all UVA light gets to Earth, regardless of what's happening with the ozone layer. Ozone is the only known gas to absorb UVB, okay, in the stratosphere. All right, part two, little science mystery. So in 1974, two scientists, Roland and Molina, discovered that CFCs, which are chlorofluorocarbons, react in the stratosphere and actually attack and break down ozone molecules, which allows more UVB light to get through. That's pretty bad. So these little guys, this is your CFC, CFCs will drift into, eventually after they're used on the planet, will drift up to the stratosphere and attack the ozone molecules. It takes between 10 and 20 years for the CFCs to actually get up to the stratosphere and start doing their damage to the ozone. But once they're there, they can last between 65 and 385 years. So they're what's called persistent, very persistent chemicals. They last a really long time. For a while, at the time in the 70s, the CFC industry was like $20-some-odd billion industry. So the chemical companies did not like what these scientists were saying. So they basically said, hey, you guys are crazy. They tried to discredit their research. And then eventually, 14 years after the original research paper came out, these chemical companies stopped making CFCs. And then these guys were finally vindicated in 1995. They won a chemistry Nobel Prize. So here's the reaction in the stratosphere. So what happens is 10 to 20 years after these CFCs are released on Earth, they get up to the stratosphere. And once they're up to the stratosphere, they react with UV light, and one of the chlorines comes off. Okay, so this is the rest of the CFC molecule. We don't really care about that anymore. What we do care about is this lone chlorine guy. So again, it's a halogen, and once it splits off by itself, it's very reactive. So what this guy will do is it's going to bump into an ozone, bam, and it pulls one of the oxygen atoms off. Now this guy can't block UVB because it's not ozone anymore. So then this guy is kind of floating about. This is chlorine monoxide, not to be confused with the polyatomic ion hypochlorite, which is ClO negative one. This is actually chlorine monoxide. Well, what happens with this guy is it's going to react with one of the oxygen-free radicals that's in the stratosphere, and then have diatomic oxygen, and the chlorine floats off. Why do we care about that? We care about the fact that this chlorine atom now is free again to attack more ozone. So it's a three-step process. Step one, UV light breaks off your halogen. So you've got your chlorine. Step two, chlorine attacks ozone, and now it's not ozone anymore. Step three, these guys split apart, and you've got this free chlorine that's, again, available to attack more ozone. So literally thousands to hundreds of thousands of ozone molecules can be broken down by just one CFC molecule because this chlorine gets recycled over and over again. Okay? Part three, ozone hole. The ozone hole, and I use that term loosely, because when you think of ozone in the stratosphere, it's not like there's an actual physical hole. What happens is you have lower concentrations of your ozone molecules in the atmosphere at that point. So maybe you normally have 400 part per billion ozone molecules in a healthy stratospheric ozone layer. In areas that have ozone hole, maybe you'd have 300 or 200 parts per billion. So you just have less ozone molecules in your atmosphere. The areas that tend to have the biggest reduction in concentration in ozone are above your poles, both the Arctic and Antarctic. One of the reasons is that these CFC molecules, specifically the chlorine atoms, get stuck in this band of wind called the polar vortex. Polar vortex. They get stuck in the polar vortex and just break down ozone and ozone and ozone in the North Pole and the South Pole. Additionally, special high altitude clouds in these regions, the polar regions, help kind of give reaction surfaces basically for this reaction to happen. What happens is the polar vortex winds kind of shift a bit, and areas of the southern hemisphere and kind of like at the top of the northern hemisphere get the ozone hole. So for example, some areas of Australia and New Zealand in some parts of the year get their UVB amount that comes through the ozone layer, that it can increase up to almost 20 to 25% in certain seasons. So the Montreal Protocol in 1987 is a piece of like groundbreaking legislation. Pretty much most of the countries in the world signed on to the Montreal Protocol, which agreed to cut CFC production first in half, then in half again, and then eventually phase it out. Today, the production of ozone-depleting chemicals has decreased by about 95%. The Montreal Protocol is considered one of the greatest environmental success stories because we got worldwide cooperation on a recognized problem, and the ozone hole is getting better, and we're not really producing CFCs anymore that damage the ozone. So it's been really a success story. Okay, part 4, why do we care about UVB? Remember, less ozone equals more UVB. What's UVB going to do? It's going to give you skin cancer. That's bad. It's also going to give you sunburn and gives you cataract, eye damage, and actually suppresses the immune system. In the ecosystem, especially in our polar regions where we have a thinner ozone layer, it will kill off polar phytoplankton, which is the base of that food chain. So there's massive disruption in polar marine ecosystems. It will directly damage fish and amphibians. They give them little like nasty sores. So UVB kind of gives them like, not necessarily skin cancer, but it gives them like bleeding sores. It's really gross. And then it decreases plant productivity as well, so we can't have as much plant production, so that's bad. Let's talk about ozone in the troposphere. Okay, so, which is part 5. So, my saying it's so good, too bad. Say it with me. Ready, go. So good, too bad. If you notice the saying above me, so has 3 O's, right? Ozone, O3, is good in the stratosphere. So good, too bad. Ozone, O3, is bad in the troposphere. Okay, here's the deal. In the stratosphere, ozone is actually formed from UVC light. Good thing, protects us from UVB. In the troposphere, ozone is actually produced from reactions from stuff from car exhaust plus sunlight, plus UV, primarily UVB. So in any case, it's produced totally different as a secondary pollutant in the troposphere. It's actually really bad for us. It's a major respiratory irritant. If you've got any underlying lung conditions at all, asthma, emphysema, bronchitis, a bad respiratory gunk, all of that will be really aggravated with ozone. It makes you cough. It actually scars your lungs, especially if you're a kid, as your lungs are developing. That's a really, really bad thing. So pretty much, ozone is really bad in the troposphere. It will also bleach plants and kind of spot them, and it can lead to plant diseases and stress out the plants. Ozone is the most frequently violated urban air standard in the United States. That's why when you hear in Austin, oh, it's an ozone action day, that doesn't mean like go outside because there's more ozone in the stratosphere and you're going to get less sunburn. It means no, we've been driving our cars too much in the sun, and it's going to make you cough and get respiratory problems. Okay, thank you. That's ozone.